Ratio and proportion. John is mixing sand and cement to make a concrete path. So here's John, and he's mixing up the sand and cement because he wants to make a concrete path. He has sand and cement in bags of equal size. John wants the mixture to have 5 bags of sand for every 1 bag of cement. This will give him the strength of concrete he needs. In mathematics, we say that John wants the ratio of sand to cement to be 5 to 1. So every 5 parts of sand, there's going to be 1 part of cement. The order in which you write or you say sand and cement is extremely important, because if this had said the ratio of cement to sand, it would have been totally different. So the ratio of sand to cement is 5 to 1. So the first word is sand, and the first number is 5, so that's 5 parts of sand. And the second word is cement, and the second number is 1, so that's 1 part of cement. So 5 parts of sand for every 1 part of cement, or 5 bags of sand for every 1 bag of cement. When we compare €36 to €12 using the idea of how many times €36 is bigger than €12, we can call this the ratio 36 to 12. So 36 ... 12. So 36 is to 12. 36 is 3 times €12. We can write many pairs of numbers in the same ratio as 36 to 12. So for example, 36 to 12 is the same thing as 72 to 24, which is the same thing as 18 to 6, which is equal to 12 to 4, which is equal to 9 to 3, which is equal to 6 to 2, which is equal to 3 to 1. So they all actually represent the same ratio. We get ratios equivalent to 36 to 12 by multiplying or dividing each number in the ratio by the same number. So what we do to the left, we do to the right. What we do to the right, we do to the left. You will remember that we use the very same method when we write equivalent fractions. So for example, 3/4 is equal to 6/8 is equal to 9/12 is equal to 12/16, etc. Fractions are also ratios. So when we're simplifying fractions, the rule is what we do to the top, we do to the bottom, what we do to the bottom, we do to the top. A ratio is a quotient of 2 numbers giving their relative size. Ratios can be written in different forms. So A over B is equal to A to B. For example, 3 to 5 means that for every 3 portions of the first amount you have 5 portions of the second amount. This ratio can also be written as 3/5, or we can say 3 is to 5. Ratios, just like fractions, are usually written in their lowest terms, their most simplified terms, i.e. 15 to 3 is equal to 5 to 1, because we can divide both sides by 3. So 15 divided by 3 gives us 5, and 3 divided by 3 gives us 1. When we have a statement of equivalent ratios, we have a proportion. This is sometimes called a direct proportion. A famous ratio found in nature is the golden ratio, so pronounced phi, which is approximately 1 to 1.618. It is found in the natural world, such as in snowflakes or plants, in architecture, and in the ratio of measurements of humans. Indeed, it has even been claimed that the golden ratio is the mathematics behind beauty. So let's have a look at some examples where we simplify ratios. Rewrite each of the following ratios in its simplest form. So part 1, 10 to 25. So we need to think what number will divide evenly into 10 that will also divide evenly into 25. And we always want the highest number, so it's the highest common factor we're actually looking for. So that number is 5. So what we do to the left, we do to the right. So 10 divided by 5 is going to be 2. And 25 divided by 5 is going to be 5. So 10 to 25 can be simplified as 2 to 5. So it doesn't matter what number you divide in, so long as what you do to the left, you do to the right, what you do to the right, you do to the left. So this is our answer here. 10 to 25 simplifies as 2 to 5. But we can actually rewrite 2 and 5 as fractions. So 2 plus 5 gives us 7, so there's 7 parts in total. So this 2 represents 2/7 of the whole amount, and this 5 represents 5/7 of the whole amount. So we weren't actually asked to do that. All we have to do is come up with the simplified ratio, which is 2 to 5. So this is the answer here. But in some questions that we'll see later on, this is going to be very, very helpful. So it's no harm to have a look at it now. We're going to do the same thing now with 36 to 42 to 60. So what's the highest common factor that will divide into all of those numbers? And the answer is 6. So 36 divided by 6 gives us 6. 42 divided by 6 gives us 7. And 60 divided by 6 gives us 10. So this ratio simplifies as 6 to 7 to 10. So this is our answer. But just like in the previous question, I'm going to just rewrite each of these numbers as fractions. So the first thing we do is add up the amounts. So 6 plus 7 plus 10 gives us 23. So this 6 represents 6/23 of the whole amount. This 7 represents 7/23 of the whole amount. And this 10 represents 10/23 of the whole amount. Rewrite each of these of the following ratios in its simplest form. So 450 grams to 1 kilogram. Now before we start to simplify, hopefully you can notice that we've got grams on the left, kilograms on the right. So we have to have the same unit of measurement. So we can either have them both in grams or both in kilograms. So I'm going to change them both to grams. So 450 grams is already in grams, so that just stays the same. And 1 kilogram is actually 1,000 grams. There's 1,000 grams in a kilogram. You need to learn this off by heart. So now that we have them in the same unit, we can simplify. So what number will divide into 450 that will also divide into 1,000? What's the highest common factor? Now the highest common factor happens to be 50, but let's say that you didn't spot that straight away. So let's say that you noticed that 10 will divide into both of them. Well, we can divide both by 10, and 450 divided by 10 is 45. And 1,000 divided by 10 is 100. So remember, what you do to the left, you do to the right. What you do to the right, you do to the left. However, this is not in its simplest form, so we're going to have to go again. So what will divide into 45? That will also divide into 100. And the answer is 5. 45 divided by 5 is 9. 100 divided by 5 is 20. Now we can't simplify any further. There's no number that will divide into 9 and also into 20. So 9 to 20 is our final answer. It's our simplified ratio. So you could have straight away at the very start, well, once you had both units in grams, you could have just divided both sides by 50. But if you don't spot the highest common factor straight away, you can divide in numbers that you do recognize. So you might have noticed that 10 would divide into both sides, and then when you had done that, hopefully you would then notice that 5 would divide into both sides. So 9 to 20 is our answer, but just like in the previous examples, we're going to just rewrite them as fractions because it's going to help us with some questions later on. So 9 plus 20 gives us 29. So that 9 there represents 9/29 of the whole amount, and that 20 there represents 20/29 of the whole amount. In the last example here, we have fractions, so we have to do something different. So we have a quarter is to a sixth. So we have a look at the denominators, 4 and 6, and this time we want to get the lowest common multiple. So we write out the multiples of 4, 4, 8, 12, 16, dot, dot, dot. We write out the multiples of 6, 6, 12, 18, 24, dot, dot, dot. We can clearly see the lowest common multiple is 12. So whenever you've got fractions in ratios that you want to simplify, you look at the denominators, the numbers on the bottom, you get the multiples of the denominators, and you find the lowest common multiple of the denominators. And then you multiply the left and the right by the LCM. So I'm going to multiply the left-hand side by 12 and the right-hand side by 12. So a quarter multiplied by 12 is the same thing as a quarter of 12. And a quarter of 12 is 3. So a quarter multiplied by 12 is 3. And then a sixth multiplied by 12 is the same thing as a sixth of 12, which is 2. So this ratio simplifies as 3 to 2. So 3 plus 2 is 5, so this 3 represents 3/5 of the whole amount, and this 2 represents 2/5 of the whole amount. In an election, Siobhan got 3 votes for every 2 votes that Thomas got. Siobhan got 72 votes. How many votes did Thomas get? So we start off by writing Siobhan to Thomas. And underneath Siobhan we write 3 because Siobhan got 3 votes. And underneath Thomas we write 2 because Thomas got 2 votes for every 3 votes that Siobhan got. So Siobhan got 3 votes for every 2 votes that Thomas got. Siobhan got 72 votes, so underneath the 3 we can write 72. How many votes did Thomas get? So we don't know how many votes Thomas got, so we can just call that X. So the original ratio is 3 to 2. We know Siobhan got 72 votes. We need to figure out how many votes Thomas got. So we need to think, well, how do we get from 3 to 72? And with ratios, we can only multiply or divide. So you're going from a smaller number, 3, to a bigger number, 72. So we must be multiplying. So what do we multiply 3 by to get to 72? And if you can't think of what it is, you can go the opposite. What is 72 divided by 3? And the answer is 24. So 3 multiplied by 24 gives us 72. So what we do to the left, we must do to the right. So we're going to do 2 multiplied by 24. And 2 multiplied by 24 is 48. So X is equal to 2 times 24, which is 48. Therefore, Thomas got 48 votes. Alan, Brian and Kathy share a prize fund of €500 in the ratio 5 to 3 to 2. Find each person's share. So the first thing we want to do is to add up the ratios. So 5 plus 3 plus 2 gives us 10. So we write out the names in the order they were given. So Alan to Brian to Kathy. And next we write the ratios, 5 to 3 to 2. So Alan gets 5 parts of the total amount, Brian gets 3 parts, and Kathy gets 2 parts. So the order is very important. Alan came first, and 5 was the first number. Brian came second, and 3 was the second number. And Kathy came third, and 2 was the third number. So it's very important that the numbers match up with the people. So 5 plus 3 plus 2 gives us 10. So that means Alan gets 5/10 of the whole amount. So Alan gets 5/10 of €500. Brian's ratio is 3, so Brian gets 3/10 of €500. And Kathy's ratio is 2, so she gets 2/10 of €500. Remember the 10, the denominator, came from up here where we added up the ratios. Of in maths means multiply. So to get 5/10 of 500, we're going to do 5/10 multiplied by 500. And 5/10 multiplied by 500 is €250. Likewise, 3/10 of 500 is going to be 3/10 multiplied by 500, which is €150. And 2/10 of 500 is going to be 2/10 multiplied by 500, which is €100. So Alan gets €250, Brian gets €150, and Kathy gets €100. And a good way to check if you've done it right is add up the amounts and see to get back to the start. So €250 plus €150 plus €100 gives us €500. In a youth club, the ratio of boys to girls is 3 to 5. If there are 18 boys in the club, how many girls are there in the club? So we write out the ratio. So we've got boys to girls, and it's in the ratio of 3 to 5. So it's very important that underneath boys you put 3 and underneath girls you put 5. If you put them the other way around, it's completely wrong. The order is extremely important in ratio. So boys to girls is 3 to 5. We know there's 18 boys in the club, so underneath 3 we can put 18. We're trying to figure out how many girls there are, so underneath 5 we can write X. So 3 to 5 is equal to 18 to X. So how do we get from 3 to 18? And we can only multiply or divide. We're going from a smaller number to a bigger number, so we're multiplying. So what do we multiply 3 by to give us 18. If you can't figure it out, you can say 18 divided by 3. So it's 6. So 3 multiplied by 6 gives us 18. So what we do to the left, we do to the right. So 5 multiplied by 6 will give us x. So x is equal to 5 times 6, which is 30. Therefore, there are 30 girls in the club. Mary can do 30 star jumps in 1 minute, and Laura can do 150 star jumps in 5 minutes. Are these ratios of star jumps to time equal? I.e., do they represent the same proportion? Explain your answer. So Mary's ratio is 30 star jumps in 1 minute, so that's 30 to 1. And Laura's ratio is 150 star jumps in 5 minutes, so that's 150 to 5. So what can we divide in both sides? We can divide both sides by 5. 150 divided by 5 is 30, and 5 divided by 5 is 1. So what you do to the left, you do to the right. What you do to the right, you do to the left. So they actually turn out to have the same ratio. So as the ratios in their simplest form are equal, then these ratios represent the same proportion. Keeping different quantities in correct proportion is very important. For example, when baking or cooking, the taste and texture depends on the proportion of ingredients. Diluting juices, enlarging photographs, making tea or coffee, mixing cement, manufacturing pharmaceuticals, making medicines. A production line in a factory can make 80 pens in 10 minutes. How many pens can be made in 1 hour? So the ratio of pens to minutes is 80 to 10. So this was given in the question, so we know that 80 pens can be made in 10 minutes. But we want to know how many pens can be made in 1 hour. So we've got two different units here. We've got minutes and hours. So we need to think, well, how many minutes are there in an hour? There's 60 minutes in an hour, and this you need to learn off by heart. So 1 hour equals 60 minutes. So we want to figure out how many pens can be made in 60 minutes. So at the moment we know how many pens can be made in 10 minutes. So let's figure out how many pens can be made in 1 minute. So to change 10 to 1, to make any number become 1, we divide by itself. So 10 divided by 10 will give us 1. So what we do to the right, we must do to the left. So 80 divided by 10 gives us 8, and 10 divided by 10 gives us 1. So we now know that 8 pens can be made in 1 minute. So the ratio of pens to minutes is now 8 to 1. So 8 pens can now be made in 1 minute. Now we want to figure out how many pens can be made in 60 minutes. So we want this 1 to become 60. So we're going to multiply both sides by 60. So just to remind you that 8 to 1 means in English makes 8 pens in 1 minute. So 8 times 60 is 480. So therefore 480 pens can be made in 60 minutes, which is 1 hour. So we figured out that 8 pens can be made in 1 minute. We wanted to know how many pens could be made in 60 minutes. So 8 times 60 is 480. So 480 pens can be made in 60 minutes, which is the same thing as 1 hour. Find the value of x in the proportion 15 to 45 equals 5 to x. So we have 15 to 45 is equal to 5 to x. So I'm just writing them out underneath each other. So the first numbers, 15 was the first number in the first ratio, and 5 was the first number in the second ratio, so they go on the left. And then 45 was the second number in the first ratio, and x was the second term in the second ratio. So 45 and x go on the right. So 15 to 45 is equal to 5 to x. So we need to figure out what this x is. So how did 15 become 5? So what did we do to 15 to make it become 5? So we're going from a bigger number, 15, to a smaller number, 5, so we're dividing. So what do we divide 15 by to get to 5? And the answer is 3. So if we divide by 3 on the left, we must divide by 3 on the right. And 45 divided by 3 gives us 15. So x is equal to 45 divided by 3, which is 15. Find the value of x in the proportion 4 to 5 is equal to x to 80. So we're going to do this in the same way. So we're going to write 4 to 5, and underneath it, we're going to write x to 80. So we've 4 to 5 on the top and x to 80 on the bottom. So how did we get from 5 to 80? So we're going from a smaller number 5 to a bigger number 80, so we must be multiplying. So what do we multiply 5 by so that we end up with 80? If you can't think off the top of your head, go the other way. 80 divided by 5 gives us what? And the answer is 16. So 5 multiplied by 16 gives us 80. So what we do to the right, we must do to the left. So 4 multiplied by 16 will give us x. So x is equal to 4 times 16, which is 64. We can use a ratio table to help identify patterns when problem solving. Each ratio in the table will be equivalent to all the other ratios. We can also represent the ratios on a graph. A baker uses 1 kilogram of flour to make 8 cakes and 3 kilograms of flour to make 24 cakes. Using the information given, complete the ratio table. So the amount of flour starts at 0 kilograms, then 1 kilogram, 2 kilogram, 3 kilogram, 6 kilogram, 10 kilogram. The number of cakes, we don't know how many cakes we'll get with 0 kilograms. Well, that should be obvious. If you have no flour, you have no cakes. We know that 1 kilogram gives us 8 cakes. We don't know what 2 kilograms will give us. We know 3 kilograms gives us 24 cakes. And we don't know what 6 kilograms or 10 kilograms of flour will give us. So we need to figure out what goes in the boxes first of all. Using the pattern we will have found up here, we need to find out how many cakes could be made with 25 kilograms of flour. So you obviously have to work out the answer to part 1 before you can do part 2. And part 3, draw a graph showing the relationship between the amounts of flour and the number of cakes. So let's work out part 1 first of all. So let's figure out what goes in these gaps. So we know that 1 kilogram equals 8 cakes. That was given in the question. So 2 kilograms must be 8 times 2, which is 16 cakes. So 16 must go in this box here. We know from the question 3 kilograms gives us 24 cakes, but we can see the pattern. 3 kilograms is going to be 8 times 3, which is 24. So that was already filled in for us. So 6 kilograms is going to be 8 times 6, which will be 48 cakes. And 10 kilograms will be 8 times 10, which will be 80 cakes. And if we have 0 kilograms of flour, then we have 0 cakes. So 0 goes in the first box here. So this is just showing the filled in table and showing where the numbers came from. So 2 kilograms gives us 16 cakes because 8 times 2 is 16. 6 kilograms gives us 48 cakes because 8 times 6 is 48. And 10 kilograms gives us 80 cakes because 8 times 10 gives us 80. Part 2. Using the pattern found in part 1, find how many cakes could be made with 25 kilograms of flour. So this was the pattern again. So 1 kilogram gives us 8 cakes, 2 kilograms is 8 cakes times 2 is 16 cakes, 3 kilograms is 8 cakes times 3, which is 24 cakes, 6 kilograms is 8 cakes times 6, which is 48 cakes, and so on. So hopefully you notice that multiplying by 8 is the pattern. So using the pattern above, the number of cakes made from 25 kilograms of flour will be 8 cakes multiplied by the amount of flour. So that's 8 cakes multiplied by 25, which gives us 200 cakes. Part 3. Draw a graph showing the relationship between the amounts of flour and the number of cakes. So our x-axis goes from 0 to 10 because we've only gone up as far as 10 kilograms. So these numbers here are going to represent our x-axis. And then our y-axis is the number of cakes, and that goes up as far as 80. So the second row, the number of cakes, that will be for our y-axis. So again, the first row, the amount of flour, is going to be our x-axis. So this entire row here, 0, 1, 2, 3, 6, 10, this is our x-axis. This is our x-axis going across. And then the second row, the number of cakes, 0, 8, 16, 24, 48, and 80, that's going to be our y values. And this is our y-axis. So our x-axis going across is the amount of flour in kilograms, and our y-axis going down is the number of cakes. So 0, 0 is our first point that we're going to plot on our xy axis. So there's 0, 0 at the origin. Then 1, 8 is going to be our second point. So there's 1, 8. So it matches up with 1 on the x-axis, 8 on the y-axis. Then 2, 16. There's 2, 16. Matches up with 2 on the x-axis, 16 on the y-axis. Then 3, 24. There's 3, 24. Matches up with 3 on the x-axis, 24 on the y-axis. Then 6, 48. There's 6, 48. Matches up with 6 on the x-axis, 48 on the y-axis. And then 10, 80. There's 10, 80. Matches up with 10 on the x-axis and 80 on the y-axis. So when you plot all your points, you should be able to join them together with a straight line. And the reason that they form a straight line is that they are going up by a constant amount every time. They are going up by 8 every time. So here is our graph showing the relationship between the amounts of flour and the number of cakes. So the relationship between them is constant.